All right, 6.1, page 251. We should all be on page 251 in our books. Page 251 in your books. All right, in example 1, we're just writing integers, okay? And this is more of a real-world example. You'll have a little bit of this on your homework tonight as well, okay? If I said that, and we can just attach a name to it, Maurice Jones-Drew had a 7-yard gain. 7-yard gain. Not too unreasonable. Jaguars won last Sunday, so, okay. How would I represent that as an integer? How could I write that? How would I write it, Ethan?
7 over 0.
7. Because it was a 7-yard gain, it's positive 7. That's how I would write it as an integer. What if I said, and this I guess is maybe a little more typical of the Jaguars, they had a 10-yard loss. How would you represent that as an integer? Tyler? Negative 10. Okay? And we're talking in terms of positive and negative. So that's the terminology that I want you to use. All right, now let's go through a few more examples. All right? Chandler went to Foot Locker and he spent $50. How would you represent that as an integer? Negative 50, right? Let's see. What's another one? Okay, we could say that Dale slept on a bunk bed last night. He had a nightmare and he fell off 5 feet. Okay, and he bumped his head. All right, how would that be represented as an integer? Negative 5. Okay, so real world examples can be attached to positive and negative numbers. You might not realize it, but we deal with positive and negative integers every day, many times a day. So there's a real strong connection here between what you're learning in class and what applies in real life. Question. Now let's take these same numbers, okay, 7 and negative 10. All right. What is the opposite of 7?
Minus 7.
Negative 7, not minus 7. You're gonna say negative 7. Remember, we're talking in terms of positive and negative. What's the opposite of negative 10? 10. Okay. And that might seem kind of elementary to you, but it's important that you realize, that you recognize where these would fall on a number line. Okay. You're at positive 7 on one side of the number line, and exactly the same number of units away on the other side, you have negative 7. Okay, so they're the same units away from 0, just on either side of it. All right, now I want you to go ahead and do your turn now on the bottom of page 251 on your own. All right, now let's talk one more piece to this, and this is, again, going to be on your homework. You might even see this on a quiz or a test, so pay attention. All right, what if I asked you to graph or to draw a number line and graph the integer negative 3? Okay, now the hardest part is setting up the number line and making sure that your numbers are in the right order. Okay, so if you wanted to graph negative 3, you need at least 5 numbers on your number line. You want to make sure that you have this in your notes because it's part of your homework tonight. So if we're going to graph negative 3, we need 5 numbers. What numbers do you think you should put on your number line? All right, starting with the far right hash mark. What number would you want to put there?
0.
If you put 0, yeah, you can put 0.
5.
5? That's a little big. Let's start with 0. Now, what would be the next number? Negative 1, then? Negative 2. Negative 3, negative 4. Remember, the farther away the negative numbers get from 0, the larger they are, the smaller their value. And then you would plot a point on negative 3, and that's how you would graph that integer, okay? So, pretty simple. Setting up the number line is probably the hardest part, just to make sure that you get all the numbers in order. Okay? John. All right, he asked a good question. If you wanted to graph negative 78, would you want to start at 0?
No.
What 5 numbers would you want to put on a number line of negative 78, Brandon?
Go by 25.
No, you don't want to go by 25s. It's too much guesswork.
73.
Okay, you start at No, not 73. You could start at negative 75, negative 76, negative 77, negative 78, and negative 79. Remember, as long as they're going in the right order, think of it. Off here, far to the right, is going to be 0. So the farther they get from 0, the bigger the number. Then you would plot negative 78 right here. It would be ridiculous for me to say that you had to start at 0 and write, and we don't want to go by intervals greater than 1 or 2 because it leaves too much guesswork in between for where that point actually goes. So just start the values right around wherever that value is that you're graphing. All right, now in example 2, we're comparing integers. So if I wanted to compare 3 to negative 1, I always read it left to right. So is 3 greater than or less than negative 1? It's greater than. Any positive number will always be bigger than a negative number. But what if you had negative 7 and negative 10? Is negative 7 greater than or less than negative 10? It's greater than, because remember, the larger the negative, the smaller the value. The farther it is away from 0. What if you had negative 2 and negative 1? Negative 2 is less than negative 1, okay? Now, some of you just, said negative 1. Well, negative 1 is what? Okay, remember to read it left to right. Negative 2 is less than negative 1. That'll keep you from getting confused. All right, any questions on that? All right, I want you to go ahead and do numbers 5 through 8 on your turn now. All right, now we have example 3. In example 3, we're ordering integers on a number line. The question asked me to identify the least average temperature and then to graph it on a number line. So what's the least average temperature? What is it? I heard it. What is it? Negative 15, and that's in what month?
February.
Nope. January. Very good. Okay, so since the least average temperature is negative 15, and this kind of goes back to whenever we did some graphing, how do we know where to start our interval? Well, if the lowest number is negative 15, I want to start just under that. So I'm going to start at negative 16. All right, and I'll increase by 2's, which is fine. Now, why did I end it at 8? Why didn't I go up to 20 or 30? Why did I end my number line at 8? Look at your chart and tell me why you think I ended my number line there, besides the fact that I ran out of room. What do you think? Why stop at 8? Why not 20, 30? Chandler?
Because it's the same on the...
Look at the chart on page 252. Look at the chart. Piper? Because 6 is the greatest temperature. There's no other temperature higher than 6, so there's no reason to continue my number line. All right, so we said that negative 15 degrees is January. Make sure you label each point on the number line. It doesn't make any sense to have a bunch of points and not have their labels. You don't know what value which point stands for. Okay? What's the next lowest value? December, which is negative 14 degrees. What about the next one? February, which is negative 12. What's the next one? November, which is negative 6, and then March, and then April. Okay, so we graphed these values on a number line. All right, you're going to have a little bit of that on your homework tonight as well. All right. Now, I want you to graph negative 4 on a number line. Okay, now yours doesn't have to exactly match this, but some numbers you could put on here are negative 1, 2, 3, 4, and 5, and then you would plot the point on negative 4. Okay, like I said, you didn't have to have those exact numbers. You could have started at negative 3. Okay, as long as you have negative 4 on there somewhere and you plotted the point, that's fine. All right, now I want you to give me, and raise your hand, but give me a value for M that would make this true. What is a value for M that would make this true? Brandon? Okay, 3. What's another value? Jonathan?
Negative 15.
No.
15.
15. Yes, that would be true. Chandler?
-1.
-1, yeah, that would be barely true. Vanessa? 0, very good. Ethan? 2. Okay, so any number, guys, there's a million different numbers you could choose, and actually you could choose 1,000,000 if you wanted to, okay? So on your homework tonight, you have a section like this. Just make sure that you substitute in and ask you to give 2 integers that would make it true. So just make sure that you give 2. All right, any other questions on example 3 before we move on? Any questions? All right, one last thing I want to talk about, and this is kind of jumping the gun a little bit because we're going to talk about absolute value tomorrow. But I want to introduce it to you today so it's not the first time you've seen it when we talk about it tomorrow. The absolute value of a number is represented with 2 bars around the number. And here's what it means. The absolute value of a number is the number itself, how many units it is away from 0. It's not positive, it's not negative. I'm just asking myself, how many units is it away from 0? So it's not positive or negative. So basically, the absolute value is just the number without its sign. So absolute value of -7 is 7. Absolute value of 15 is 15. What's the absolute value of -4?
4.
Just 4. Okay. What's the absolute value of -8?
8.
Just 8. What's the absolute value of 2?
2.
Just 2. So let me ask you this. What is 3 times the absolute value of -4?
12.
Is it 12?
-12.
Is it -12? It's 12. Because what's the absolute value of -4? 4. And 3 times 4 would be 12. Okay? All right, so that's just one way that we can use absolute value. We're going to use it a different way tomorrow, but it's important that you just kind of remember that for our lessons that are coming up. All right, and if you understand that, that's everything you need to know for 6.1.